Today we are going to learn about optimizing TensorFlow models with hyperparameter tuning. We will explore essential techniques to fine-tune hyperparameters in TensorFlow models to enhance performance and accuracy.
Welcome to our tutorial on optimizing TensorFlow models with hyperparameter tuning. In the world of machine learning, hyperparameters are the parameters that govern the training process and model architecture. Unlike model parameters, these are not learned from the data but set prior to training. Correctly tuning these hyperparameters can significantly impact the performance of your model, enabling you to achieve superior accuracy and efficiency. Today, we will delve into the key techniques of hyperparameter tuning using TensorFlow, equipping you with the skills to enhance your model's capability through effective experimentation and strategic adjustments.
In this segment, we'll explore the various hyperparameters that are crucial in the training of neural networks. Hyperparameters are settings that influence the training process and final model structure, such as learning rate, batch size, number of epochs, and architecture-specific settings like the number of layers or nodes per layer. The learning rate determines how quickly or slowly a model learns from data, while batch size refers to the number of samples processed before the model is updated. Each of these plays a distinct role in shaping the model's learning process and final performance. Understanding their direct and indirect impacts can help you make informed decisions when setting up a model. In practice, determining the right combination of hyperparameters is often an iterative process that requires careful experimentation and analysis.
Now, we'll compare two popular hyperparameter tuning methods, grid search and random search. Grid search involves an exhaustive search through a manually specified subset of the hyperparameter space. It systematically builds and evaluates a model for each combination of algorithm parameters specified in a grid. While it is comprehensive, it can be computationally expensive. On the other hand, random search randomly samples the search space and evaluates a fixed number of configurations. It is often more efficient than grid search in high-dimensional spaces because it can discover a good combination of hyperparameters with fewer trials. Each method has its pros and cons, and the choice between the two often depends on the specific problem you are tackling, the computational resources available, and the time constraints you face. TensorBoard is an essential tool for visualizing and tracking the performance of your TensorFlow models. It lets you visualize metrics like loss and accuracy, and can also be used to monitor hyperparameter tuning experiments. By integrating TensorBoard into your workflow, you can gain valuable insights into how changes in hyperparameter settings affect your model's performance. To set up TensorBoard, you need to log your model's performance metrics during training. Once set up, TensorBoard offers a user-friendly interface to explore these metrics, helping you make data-driven decisions to refine your model. This visual approach to tracking experiments enables you to quickly identify trends and anomalies, facilitating a more informed and efficient tuning process.
Keras Tuner is a powerful library that simplifies the process of hyperparameter tuning for TensorFlow and Keras models. It provides an easy-to-use interface to define and search through hyperparameter spaces efficiently. First, set up your environment by installing Keras Tuner. Then, define your search space by specifying the hyperparameters you want to tune in their respective ranges. Keras Tuner supports multiple tuning strategies, including random search, hyperband, and Bayesian optimization. Once your search space is defined, you can initiate the tuning process. The library will automatically run multiple trials, exploring different hyperparameter combinations to find the optimal settings. After the tuning process, you can analyze the results using Keras Tuner's built-in tools to identify the best performing model configuration. After tuning your model's hyperparameters, the next crucial step is to evaluate the performance improvements achieved. This involves comparing the tuned model against its original version using a set of performance metrics such as accuracy, precision, recall, and F1 score. These metrics provide a quantitative measure of the improvements made through hyperparameter tuning. It's essential to assess these metrics on a validation dataset that was not used in the tuning process to ensure the model's generalizability. Comparative analysis of the results can reveal insights into the effectiveness of different hyperparameter configurations. Interpreting these results will help you understand the strengths and weaknesses of your model, guiding future tuning efforts. Remember, hyperparameter tuning is an ongoing process of refinement and optimization. For large-scale projects, automating hyperparameter tuning with cloud-based solutions like Google Cloud AI Platform can be highly beneficial. This platform provides robust tools for automating the tuning process, leveraging Google's powerful infrastructure to handle extensive hyperparameter searches efficiently. To get started, you'll need to set up your model and specify the hyperparameter search space and objective metric. The AI platform will then automate the tuning process, running multiple experiments in parallel to accelerate the discovery of optimal hyperparameter settings. The scalability and efficiency offered by Google Cloud AI Platform make it an ideal choice for handling complex models and large datasets. By integrating it with TensorFlow, you can streamline your workflow and focus more on model development rather than the intricacies of tuning.
In hyperparameter tuning, following best practices can significantly enhance the efficiency and effectiveness of your efforts. Begin with a broad search across the hyperparameter space to identify promising regions before narrowing down the search. Use domain knowledge to inform your choices, focusing on hyperparameters known to significantly impact model performance. Balance your approach between exploration of new hyperparameters and exploitation of known good settings to avoid getting stuck in local optima. Prioritize tuning key hyperparameters that are known to have the most significant effect on model outcomes. Finally, remember that tuning is an iterative process. Continuously refine your approach based on the insights gained from each round of experiments, and be prepared to revisit and adjust your strategies as new data and techniques become available. As we conclude this tutorial on optimizing TensorFlow models with hyperparameter tuning, let's recap the key points we've covered. Hyperparameter tuning is vital for enhancing model performance and accuracy. We've explored various techniques, including grid search, random search, and the use of powerful tools like TensorBoard and Keras Tuner. We've also discussed the benefits of automating tuning processes with platforms like Google Cloud AI. Remember, tuning is about continuous learning and refinement, and applying these techniques will undoubtedly lead to better model outcomes. As you continue your journey in machine learning, keep experimenting, refining, and exploring new approaches to push the boundaries of what's possible.